Welcome back, and today's video is about arithmetic sequences, also known as arithmetic progressions. So in this video, we're solely going to focus on the general term, that is what is in the yellow box here, and I have a series of questions. If you want to pause the video and work through them at your own pace and then unpause and check your answer, please do so. Otherwise, we'll dive in. Okay, so let's very briefly define the general term and where this actually comes from. Well, imagine you had a sequence, something like 3, 6, 9, 12. This is an arithmetic sequence because the common difference between each term is consistent, and in this case it is +3. Now it can be negative, remember? But if we go ahead and define this as the first term, the second term, third term, and fourth term, then what we want to do is we want to come up with a formula that will basically tell us any term of the sequence. Let's say I want to find the 50th term. Well, if we look at the term and break it into this, that would be u1 plus d, then u1 plus 2 lots of d, and then u1 plus 3 lots of d. Well, notice the pattern that's happening here is that the number of d's, like the number of common differences, is always one less than the term number. Here you can see that we added 2d and the term number was 3. That is where we get this from. Okay, so the value that you times d by is always one less than the actual term number, and you will always have the first term plus that number of differences will result in the term that you're trying to find. So for example, like I said a moment ago, if I wanted to find u50 would be the first term plus 49 differences. Okay, and that's where the general term comes from.
Alrighty then.
Okay, question 1. Consider the sequence 2, 9, 16, 23, and 30. Show that the sequence is arithmetic. Okay, to show that something is arithmetic, what we need to prove is that one term minus the previous term must always equal d. So we can just show that this is arithmetic because if we have 9 minus 2, that would equal 7. So it looks like it's a common difference of 7. And then we can show by using another term, which is like 16 minus the previous term, 9, that will also equal 7. And we can continue this and say that 23 minus 16 is also 7, and so on. So this is proving that the common difference, between all of the terms is the same, and this is 7. So that would answer part A. Okay, let's look at part B. Find the formula for the general term. Okay, so that's the nth term or the general term. We saw above that that would be in the form un is equal to u1 plus n minus 1d. So it's just a case of substituting everything in. Now, un stands for the nth term or the general term, so that would stay exactly the same. But u1 in this case is the first term of the sequence. That is 2. So let's go ahead and plug that in. 2 plus. Now, here what we'll do is we must leave n in because it's the general term, so we don't know. We want to be able to substitute a value for n in the future. Okay, so we're going to leave that as n minus 1, but we do know that the common difference between each term is 7. Okay, so what you'll do is, in this case, is you usually times this out and simplify it up. So you get plus 7n, and then you've got 7 times minus 1, which is minus 7. So you can tidy all this up to be negative 5 plus 7n, and that is our general term. So we're going to be using that in the next part of the question, but that is part B complete. So it says find the 100th term of the sequence. Okay, so the 100th term, so here's part C now, is un is equal to minus 5 plus 7n, but the 100th term will be u100 is equal to negative 5 plus, now this would be 7 times 100, that would be 700, subtract 5. So that would be 695, and that is the value of the 100th term. Okay, so let's look at part D. So is 828 a term of the sequence? And then in part 2 of that question, it's is 2341 a term of the sequence? So there's a very particular way you can do this, and that's just assume that 828 actually is in the sequence. Okay, so DI, we want to know if, well, let's take our general term. So un equals negative 5 plus 7n. And we're going to assume that 828 is actually in the sequence. So 828 is equal to minus 5 plus 7n. And I'm going to add 5 to both sides. So sum 5 to both sides, leaving this. And we just want to see if we can divide both sides by 7. And if it goes exactly, then we have a integer for n, which is exactly what we would want. When we do that on a calculator or just by a long division, you will find that it's 119. So yes, that means that 828 is in the sequence. If that comes out to be not an integer, so like a fraction, then n cannot be a fraction because n is a term number. So it needs to be an integer. It cannot be a fraction. So let's look at part II now. They want us to know, ask us if 2,341 is in the sequence. So 2,341, again, equate that to our general term. Comes out to be, so using a calculator again, it's a fraction. So it's actually 335 and 1/7. Right, so that's not good. So no, that is not in the sequence because n must be an integer because n is a term number. So therefore, we've established that that number is not in the sequence. Okay, question 2. So find k given that this value, and this value are consecutive. Now, consecutive means one after another. So it doesn't matter where they fall in the sequence. We just know that they fall one after another. So therefore, then, if we have 3k plus 1, and then another term, k, and then another term, minus 3, you could, if you wanted to, assume that that's u1, u2, and u3, but that is not necessary here. We don't actually know. They are 3 consecutive terms within a sequence. And to be honest, it doesn't really matter. What we do know is this is true. If we take the one value and we subtract the previous value, so that would be like taking u2 minus u1, for example. Like I said, it doesn't matter that it's 1 and 2. This would hold for any part of the sequence. So one term, subtract the previous term, and that would be the 3k plus 1, right? Would be equal to, and we can say that statement again, right? So we would take one term, that in this case would be minus 3, subtract the previous term. And if we did that, the previous term in this scenario then would be k. So what we're doing is we are taking one value of the sequence and we are subtracting the previous term, okay? And if this is arithmetic, which it tells us to, then these two terms must be equal to one another. So we're going to get k minus 3k minus 1 must equal minus 3 minus k. And let's group like terms together. I can see that I can add k to both sides. So that would become 2k. And then we've got minus 3k. Add 3 to both sides. So that become plus 2 is equal to 0. And therefore, negative k plus 2 is equal to 0. So 2 is equal to k. And therefore, we have found the value for k. Okay, example 3. Find the general term un of this arithmetic sequence that has a third term of 8 and an eighth term of minus 17. So let's set up this question using the general term formula, which is the following. And let's substitute everything in we know. So I'll deal with the third term first. So the third term, u3, is equal to u1 plus, now this will be 3 minus 1 times d, so that'll be 2d. And the third term we were told was 8, so a equals u1 plus 2d. Now I'm going to do this all over again, but looking at the eighth term. Okay, so u8 is equal to u1 plus, now n minus 1 will be 8 minus 1 times d, so that'd be 7d, and the eighth term is minus 17. So we have two equations, two unknowns. So I'm going to solve these using simultaneous equations. Now you can use either substitution or elimination, whichever you're more familiar with, but I'm just going to stack them on top of one another like so. Like I said, there's different techniques to solve simultaneous equations. You might not like this one, so choose your method. Now what I'm going to do is I can see that if I subtract the lower equation away from the upper, the u1s will cancel, like here. So u1, subtract u1, that will go to 0. So that's gone. Now I'll deal with the d's. So 7d minus 2d will be 5d, and negative 17 minus 8 would be minus 25. And if I divide both sides by 5, I get d is minus 5. So I'm saying that the common difference between all of the terms is negative 5, right? Okay, so the question's asking us to find the general term un. So we've still got a little bit more work to do here. the general term will be un is equal to u1 plus n minus 1 d. Now, the issue that we've got here is we don't actually know what u1 is, okay? But we can easily find u1. So if we go back up to here, I'm just going to use this bit of information here. So we can say that u3, which was 8, so u3 is equal to u1 plus n minus 1 times d. So that was 2d, but now we've got d. We found d. d is minus 5. So 2 times minus 5 is minus 10, right? So we've got 8, is equal to u1 minus 10. Add 10 to both sides, therefore u1 will be 18. Sorry, I'm moving up the screen here, but u1 would be 18. So therefore then we're going to substitute that in now. So our general term un is 18 plus n minus 1d. Now, n minus 1 times negative 5. Now, we don't usually leave things in that form. We'll use that timesing out sort of FOIL method there, minus 5. So un equals 18, and then we'll get minus 5n, okay, plus 5. And we'll combine like terms. So that's going to be 23 minus 5n is equal to our un, and that is the answer to the question. That is our general form, our nth term. Okay, on to the last example for this video. Insert 4 numbers between 3 and 12 so that the 6 numbers are in an arithmetic sequence. So this is an interesting question. We've got 3, and then we have to insert 4 numbers, okay, into here. So there's 6 terms. It's 1, 2, 3, 4. Now, what I like to do when I'm doing these questions is set these up in sort of arithmetic notation. So this first term would be u1. So the next term would be u1 plus d, and then the next term will be u1 plus 2 lots of d, and then u1 plus 3 lots of d, 4 lots of d on the next one, and then we have this 12, which would be u1 plus 5d. Okay, so we can see using this last part of that this term here is 12 is equal to whatever that u1 plus 5d is. And we knew what u1 was. That was 3. So 12 equals 3 plus 5d. Take 3 off both sides. So that's 9 is equal to 5d. Now, this is going to be a decimal or like not an integer. So d is equal to 9 over 5. Okay, and using a calculator, that comes out to be 1.8. So therefore, then, if we had to write down the numbers, we're just going to have to add 1.8 on to everything starting from 3. So we're going to get 3, and then 4.8. So let's put commas in here. And then 6.6, comma, 8.4, comma, 10.2, comma, and 12. And there are our 6 numbers in an arithmetic sequence, all with the same common difference. Okay, so that's arithmetic sequences. I hope you found the examples useful. Would you like me to go through more examples? How do you get on? Please post your comments below. Let me know. Hit the bell notification for further videos. Don't forget to like and subscribe, and I'll see you next time.